I hope all of you are in good health. Today, we will complete our lesson, Reflection and Refraction of Light. In a previous video, we talked about the meaning of refraction of light and the first law of it. And now, before starting our lesson of today, we want to remember the first law of refraction of light. When a light ray travels from a less optically dense medium as air to more, the refracted ray moves towards the normal at the point of incidence on the separating surface between the two medium. This is due to the optical density of second medium as glass is bigger than that of air, the first one. And now we'll talk about the second law of refraction of light. When a light ray travels from a more optically dense medium as glass to a less one as air, it refracts away from the normal at the point of incidence on the separating surface between the two medium. That is because the optical density of the first one is bigger than the second one. This is the opposite to the first law. The first law, from less optically dense to the more one. The second law, from more optically dense to the less one. What happened to the refracted ray? It refracts away from the normal. It refracted away from the normal. Okay, that is because or due to the optically dense of the first one is more than optically dense of the second medium. The ratio between the speed of light in air to another transparent medium is called the absolute refractive index, represented by N, and it's always bigger than 1. Why? Because the speed of light, it is the higher speed more than another transparent medium. The refractive index equals speed of light in air over speed of light in another medium. An example for this law: calculate the velocity of light in glass by knowing that the velocity of light in air equals 3 times 10 power 8 meter per second, and the absolute refractive index in glass equals 1.5. When starting solving this problem, we should write the law, because the law have a degree. The speed of light in glass equals speed of light in air over refractive index of glass. The result will be 2 times 10 over 8 meter per second. Meter per second is the unit of any speed. It is the unit of any velocity. We have some natural phenomena related to light reflection and refraction. The first one, apparent shapes of objects. Apparent shapes of objects. You can do this activity at home by putting a pencil in a cup of water. What do you see? The pencil, which is partially immersed in water, appears as being broken. Why? This is due to light refraction. The second natural phenomenon, apparent position of object. Any object in water is seen in apparent position slightly above its real position. Examples: a fish in water seems higher than its real position. Second one, bottom of the swimming pool filled with water seems higher than its true position. This phenomena occurs due to light refraction. So, when you want to pick up a coin which is falling in a beaker, we must look at it vertically. Vertically is mean by 90 degrees. This because the incident light ray perpendicular to the interface between air and water, it passes without refraction. So the apparent position is the real position. The third one is mirage. Mirage is a natural phenomenon that takes place on the desert roads at non specifically in the summertime, where objects on the roadside seemed as if they had inverted image on a wet road or wet area. We have homework B65 in the booklet. Thank you.